Good morning, everyone. On behalf of ASQ South Asia, I'm your host, Anindya Sarangi, head of ASQ South Asia region. It's my immense pleasure to welcome you to a webinar discussion. The entire month has been quite, I would say, eventful, with a lot of activities happening across India, across the world. We are all celebrating the month of quality, and this is another discussion which is more, I would say, more in tune with the requirement that is there in, I would say, upcoming requirement. The industry 4.0 is here, and what's the role for quality professionals, what to look out for, what is happening in the industry 4.0, and we have selected illustrious speakers and guests here who would talk about what they are doing, their ideas, and more information you'll get from that itself. I have a couple of slides. I'll share about a little bit about ASQ, what we are doing, and a little bit of background about ASQ a bit. I'll not take more than 2-3 minutes. ASQ is the oldest professional body in quality, founded way back in 1945. We presence in 140 countries through our members, community, and direct offices, like one in New Delhi, India. ASQ has a legacy and a fortune where leading quality gurus and thought leaders have headed ASQ and provided global quality thought leadership. In ASQ South Asia, we are engaged with over 350 corporate houses, 50 leading education institutions, building capabilities through our intense training methodologies and also advisory services. Our other offering includes membership, certification, research papers, and also engage our customers through various seminars, conferences, and award programs like this. I would beg your pardon. One of the most sought after award program in South Asia is the South Asia Team Excellence Award competition, where the winner of the best quality projects goes to participate directly at the International Team Excellence Award in the US. This year it's slightly delayed. We'll be kicking off sometime in February, the nominations, and we should be able to file it before the May event. As you know, that we are celebrating the month of quality, and we have been hearing from all of you, from the corporate houses to various sessions that has been happening across India, and the theme for our region has been reimagining quality, and that's the theme we are talking today as well. I shall be sharing more information as we move forward. There have been several activities. These are all set of activities that have already been there. I would also like to mention here is that we have our monthly webinar, and we encourage participants to come and participate. In fact, it's just keep a calendar open for the last week, or rather the last Saturday or a Sunday, depending upon if you have an international speaker. It will be most likely on a Saturday evening. If not, we'll have typically a lazy Sunday morning at 11 a.m. we have our session. So this time around, please, today in the evening at 6 p.m. we have Dr. Ronald Singh. He is an honorary ASQ fellow, a prominent thought leader, a modern era guru, and we'll be talking about data itself. What we're going to talk about, Quality 4.0 has also a lot of data, and in the perspective that in the uncertain times, how do we look at data as well? And I would welcome everyone to come and participate. Should you miss, it's available on our YouTube channel. You just need to put ASQ South Asia. You would be able to see all our other monthly webinars, and it talks. We touch upon every element, whether it is human, whether it is quality related directly. I would say quality touches every aspect, whether it is from the business to the people life. So we have been looking at inviting prominent thought leaders who will give the direction of where quality goes and where we want to drive quality. We also have, following Dr. Ronald Singh's presentation, we'll have session jointly conducted along with the Indian Quality Association and Service Knowledge Base, and we'll be having an expert session and panel discussion, and the topic is quality, so quality in economics, and that's going to be quality economics. And please stay back after the Ronald Singh's session as well to hear some more thoughts on quality economics. Tomorrow will be our concluding event as far as the month of celebrating Quality Month is concerned. We'll challenge the thought process on Six Sigma and future direction, and that's going to be tomorrow at 11 a.m. Don't miss that as well. So coming straight, Quality 4.0, the panel discussion for which we have all gathered here. Anish would be chairing the session. I will hand over the right to him in a short while. Along with Anish, we have Jagdish, Prasanna, and Sojan. More would be introduced by Anish itself. I want to set one context here is that ASQ, we are creating an interest group here in India itself, a technical interest group wherein we would be looking at thought leadership in how to shape modern era quality, wherein we look at the relevant quality practices already in place and is being engaged by our fraternity, plus looking at what is the new thought process, I would say the industry 4.0, and how it's going to be impacting quality people. And we're going to look at from various aspects in terms of what all tools, techniques that they need to upgrade to and would be relevant in near future is something that the interest group would be looking at it. And of course, we'll be looking at quality evangelists who would be part of this particular group, and then we look at socializing the entire thought process in terms of how relevant from its application perspective, from the the relevant with regard to the skills perspective. We do not look at quality profession as a pure tech person, but we are looking at for folks who are in tech as well and non-tech as well. So people who would be in non-tech, how they can drive quality 4.0, and that's the conversation. We are here, and there'll be series of such conversation happening over the period of time to build the idea, thought process. We'll further socialize this, and this is just the start. And with that, let me introduce quickly a few small line on Anish Cheriyan. Is a software quality assurance professional and thinker in discipline of software engineering. More he will share himself. He is also the LMC ASQ local member community chair of Bangalore. Anish, with that, I will stop here, and I'm excited to hear from you as well as from the panel itself. Yeah, over to you, Anish. Thank you so much.
Thank you, Anindya. Thank you. So first of all, thanks, Anindya, and I'm an ASQ member, so I can vouch for some of those, details, some of the resources which ASQ gives. It really helps us, to power ourselves with respect to some of the knowledge, which we would take some years, because there is a that's what this brings in. Of course, the membership fees which we pay, I would say it's worth it, because the resources is so good that which really helps us to broaden our horizon and things like that. With that word, thank you, Anindya. I will take over and introduce our panelists first, and then we can get into further details. So Anindya, can you confirm if you can see my screen? I think
yes. Yes.
Okay.
Yes.
So today, I think we will spend more time to have some open discussion. We will have around 10 to 15 minutes where each of the panelists will talk about what is their thought on Quality 4.0. I'm very sure that all members who have joined, who have taken time, from their busy schedule on a Saturday, thank you for doing that. I hope we can do justice to your time and also share the thoughts which we have, which we carry, and also learn from each other, and that's what I think we as a community can do. So what we will do is we will have every speaker talking for 10 to 15 minutes about their thoughts on the areas which they come from, and then we can have. I have a few questions which we have discussed and some open discussions which we can do, which we can share the thoughts, and we can have few minutes where we can have some open discussion, have an open chat dialogue with all of us, and questions from all of you, and then we can conclude. Okay, with that, let me introduce the panel. Some of you may know all of these members, but quickly to introduce a quick introduction about me. I am part of Harman. I work for Harman Automotive. and I lead the quality and engineering tools team. I have also experiences in ICT, telecom, and other domains. And yeah, I'm also part of ASQ Bangalore LMP, also part of BSpin. This initiative is also supported by BSpin, I would say. We have been partnering with BSpin for some of these initiatives. I'm also an IEEE senior member and also finished my PhD on software quality assurance in Agile Continuous Delivery. So I will have few points coming out from there, what we have done, what is the model which I suggest, and so on, based on some of those empirical study and research which I have done. We'll wait for that. A few introduction about Jagdish Singh Babra, works for Google. We call him Jagga. So Jagga is the technical lead for tools and infrastructure at Google G Suite products. He has 20+ years of expertise in areas of product quality, test automation, and fast release. His mission is to empower developers with the tools, practices, and testing support to increase their productivity while maintaining high quality standards. Right. So next, introduce Prasanna. Prasanna is an architect for the autonomous database cloud services at Oracle. In his role, he focuses on building next generation database cloud services targeting a large and critical enterprise work product. He has developed and delivered software in the space of communication, middleware, and databases. He has 20+ patents, and he has also developed and architected commercial grade software in many different areas. Yeah. Thank you, Prasanna. Thank you, Jagga. And we are also having Sojan James, who also works for Harman Automotive along with me. He is a system and software architect for embedded and automotive domain. He's a distinguished engineer. He's an amateur radio enthusiast and a sailor in training, and an electronics and communication engineer who switched to writing embedded software as a career choice, but keeps in touch with electronics and communication hobby. So first of all, let me welcome all of you, and also want to thank all of you for taking up your time to share your thoughts to our community. Thank you and welcome. Okay, with this I will set the context of this. I think some of these things will be repeat. Please consider this as a context setting, and I will have a brief about some of those details. And at the outset, I also want to tell some of the opinions, some of the views which we mentioned is our personal views. Of course, in the panel part, in the presentation, this does not necessarily reflect the views of the respective employers. If I can speak on behalf of all of my panelists. Okay, we have listened about Industry 4.0. It is right now, right here. Some of the things about Quality 4.0. In fact, if you do a search, there is no very, I would say, organized literature available about what is Quality 4.0. A lot of things are getting discovered. Of course, there are few good books which is there. I would say very few, and which of course talks about at certain high level. But how to contextualize it? What is there for a quality profession? What is there for a for the developer, or for a different for a manufacturing? Maybe for manufacturing there are a lot of leads, but some of those things for quality purposes is not available. But we can, of course, over the time in the coming days and years, we will have more things available. So Industry 4.0 has the power to positively impact industries like enhancing computational power and connectivity, promote human-machine interaction, focusing on analytics and intelligence, encouraging advanced production methods. Yeah, so that is the core part of it. Of course, we know about our history, where in 1700s we had Industry 4.0, where steam power has helped, and so on. Then electricity, with that there were mass production, and you can see in 1960 or 70 onwards a lot of focus on automation, the web-based approach, and computers comes in place, and now Industry 4.0 comes in with some of these improvements. So next slide I will talk about what are those ingredients which I have also covered in past. These are some of those tools, I will say technologies. There are many you can keep adding to this, but at least at a broad level, big data, the blockchains, deep learning, and the enabling technologies, machine learning, artificial intelligence. How are you going to integrate all of these things together to drive the point about how to ensure that we can have a more connected cyber physical world where things can be used, these technologies can be used together. Just an example, coming from a connected car domain. If you see, connected car doesn't they cannot exist. A car cannot exist in isolation, right? If you have to have the use case, you have the connected car where you have the ECUs which are there. This has ECUs and TCUs, and then ECU means that whatever sensors which are there in the car, it has to talk to, it has to do analysis, right, based on the data which it generates. So it has to use the protocol. So as a device, as a sensor doesn't exist in isolation. It has to use the protocol, either the 5G protocol, and ensure that it is talking to the cloud or the edge, yeah, and ensure that the data is analyzed as close as possible, and then feedback the data back to the user. If you see in this very small, very simple example which I have quoted, there are multiple different aspects. We have the IoT device, the sensors which we are talking about, which we say ECU, or the control unit, telematics control unit, which we typically say the antennas or whatever, right? That part. Then we have the protocol, the 5G technology, which is coming in from a protocol perspective. We have the cloud, yeah. So all of these things are coming together to to realize a particular use case scenario, and I'm very sure our speakers are going to talk about more such scenarios in the coming presentations. So some of the guiding principles is about ability of the system to support humans through, of course, aggregation and so on, ability of machinery and related components to connect and communicate with people, talking about transparency where information systems should be able to create virtual copies, do data analytics and so on, and of course to make decentralized decisions. So some of those design principles, this is of course at an abstracted level. There are more detailed ones we can talk about. So these are some of the guiding principles with which we can talk about from Industry 4.0. So the key point, the key value which this comes in is systems are connected, systems are automated, more and more automated, and intelligent. Yeah, and I will just go into my next slide. So till now I covered about overall what is the context of industry, what is quality 4.0 in a very, very high level. I will a little bit focus on the quality management system and also give some example about how we can utilize. So unlike you, I think we would have heard, many of you I believe are from quality or from management or technical background. We all know we are talking about quality by maybe inspection, where we have a lot of focus on inspection, audit and things like that. Then we focused on quality by design. We do, if you see from a Six Sigma perspective, DFS is design for Six Sigma, where we focus on making systems planned like that, baking the quality characteristics. We talked about quality by empowerment. The next focus, which I think we can use any name, but the key point is about how we continuously evolve our quality management system through discovering new information which comes automatically. Now, this is the trend, at least which I see, and which I see that more and more organizations are adopting, and this would be the path towards the future. And we have also experimented. I will share some example, because based on my last talk, I've also been asked that we can share some example. Of course, because of information privacy, I cannot share everything, but we can a little bit talk about it. So the key point is how we can have the quality characteristics identified, how we can have different systems like the R&D, manufacturing, supply chain, customer, get the real-time information from these systems, have decision making through AI and ML, and drive the corrective and preventive actions. And as a whole, how do we make a learning organization? Now, I would say there are many such ways you can represent this. This is one way I have represented it, and I will get into the detail. So this is actually something which we have implemented. This is from a system which we have done it. If you see, one of the bigger problem in any organization from a product development perspective is to make decision fast and getting an aggregated view. Now, many times the guys who come from quality or a management profession, they know whenever there is a ops review or there is a common review, it always sometimes gives butterflies. Yeah, and one of my previous colleagues always used to say that for a quality profession, it is called an occupational hazard. Yeah, so I mean that's what you are raising some problem, and you never expect that somebody will say, okay, very good, thank you very much for showing the problem. There will be always fires. Yeah. So though I would say those days are going to fade away, or I would say that's going to remain, but it has got a new view. How we can basically aggregate the information from, ideally from various tools basically, but ideally if you see in an ideal world we have one tool which will solve everything. But we don't live in an ideal world, right? We all know we have project management tool. I am very sure every organization is still figuring out what's the best project management tool, and there are out there every vendor showing everything that is available. But there is no one tool which is the best. There is many good tools, but we have a separate project management tool. We also have a defect management tool, which also in a sense lies separately in most of the organizations I've seen. We have CRM tools which talks to the customer relationship and their supply chain management. HR has a different tool, and the CI/CD tool. I've kind of simplified the CI/CD tool. There are a lot of details behind it related to code quality, where you have the Git Gerrit, you have the Jenkins, you have the code coverage related metrics, and so on. So my experience is that we have aggregated this in one view, and we have given a projectized view to this for easy decision making for the team. Now, why this is important in the context of quality by discovery? Because we have really streamlined a lot of our effort where this has to be done separately, and a lot of people were assigned here to drive these things. Now this is an aggregated view, real time. Now anybody can, at the click of a button, can take decisions based on the situation, what has to be done, what has to be improved, and so on. Now let me go to the next slide, which I'm talking about. So this is real. Whatever I'm talking about, this is done. Of course, I'm sure your organization also would have done it in some fashion. The message which I want to give is that if we have done exceptional, great. That is what you should make it in practice, that utilize this to make faster decisions. Don't wait for a big ops review meeting to happen that weekly or a monthly basis. Take actions then and there, and each role should be identified to take actions. Only then you can utilize your quality management system in a seamless way. Use the right tools from the big data or analytics. You can use machine learning algorithms, where you see, I think Jagdish is going to talk about some of those aspects related to how he is using machine learning into the CI/CD pipeline and making decisions, right? So how you can do that. Same way for defect management. Can you do some prediction based on the kind of defects which is coming in, about what kind of defects will come from this module, right? You can use various, of course, today the machine learning algorithms is also available out there. You can also pick what you want to drive, either the supervised based algorithm or unsupervised learning based algorithm, and so on, right? You can definitely bring that. The next two slides I'm going to talk about my research, which I have done. On this research which I have done is on what is the software quality assurance body of knowledge gap in agile continuous delivery. And why I'm bringing this context is because in the context of today's modern software engineering, there is no at least very few organization which has not adopted continuous integration. So in some sense, the manufacturing world, where there's a pipeline, we say pipeline, the assembly line has come into the kind of pipeline where you have organized everything. In this world, what is the role of a software quality assurance? Now, if you see, my thought process on this is that, I have surveyed more than 100 people across various organizations, and I have seen a pattern. More than 80% to 80% people have told that the quality body of knowledge today we have, whatever we refer, I know the famous book today, some of the people from have joined from some of the tier 1 organizations or institutions, right, where still we have, of course, the Pressmans of the world and the Somerville book, which is there, which is, in my view, it has not updated the software quality assurance. The chapter is not fully updated with whatever the modern software engineering. What happens is that there is a disconnect between the people who are coming out of the college and who has to use this at some sense in the practice. Same way for an SQA also, this body of knowledge is lacking, and that's what our community also reflected. Some of the key findings which I have based on my survey is that, at least the broad part which says is that the way we are defining the life cycle in the term of, if you say agile world, we say way of working, right? If you say less as a framework, they say life cycle definition, and how we have defined agile in some sense, how we have implemented this fundamentally has some challenge. Other point which came out is that the way we are doing audit, we are doing too much of governance. We are just the policing is more than really the aspect which has to be driven with respect to driving on a preventive fashion and so on. Other major aspects, and this has come from the quality profession, the SQAs, the product quality guys, or we in some sense say APQP or other roles, whatever name, that's fine. Some people also call business excellence. That the competency of the domain and the technical knowledge is lacking to do that particular work at that point of time. And of course, there are other deeper continuous integration related system engineering and software engineering problems, like whether are we ready, how are we writing our requirements and so on, how are we architecting for continuous delivery, the code quality related problems, how are we finding our non-functional related aspects baking into the system and so on. Okay, so what my major point which I wanted to summarize is that if we have to go into a quality 4.0 and adopt into our own product, if you have, we cannot ignore continuous delivery or periodic build or continuous integration. If you have to, the SQA or the quality as a model which the team has to bake into their process, and SQA as a profession also has to adopt this, ensure that this is used in their own profession. That is one part. Yeah. So what is the model? Of course, there's a detail. I will take this whole thing public in some time. There is a set of around 32 practices which is defined in each of this area. I would try to take a summary of this and then have Jaga speak about in his slides. So the first part is any system which we define, identify the fitness function. This is not a new name, it's always there. You can also say quality characteristics and so on. But it is just not a mere word. The point is, if you are working on a IoT platform, or IoT protocol platform, or IoT as a application development, or whatever you are doing, you must identify what is the fitness function. Maybe for a device, it's the memory constraints which are there, or how well you can optimize your protocol. Yeah, if you are working in the protocol domain for that IoT. So identify that, ensure that your life cycle means it's not some general gyan of life cycle. It's all about how are you writing your requirements, how are you ensuring your architecture is written so that your architecture is also taking parameters like, how are you monitoring, can you also deploy it properly and so on, deployability factors and all have you covered. Have you written requirements in such a way that it is granularized and our developer can typically use it or write it, check in every day? I mean, typically the problem you see, the developer starts using it and you see that developers have to be asked to check in every day, but actually the features are very large. So the point is about identify those fitness functions, have the continuous delivery readiness. Basically readiness when we talk about is that do you have the infrastructure, and there are a lot of other aspects which you're talking about. Ensure that your quality assurance is built in the pipeline. There are a lot of things around it, like how are you ensuring that your quality assurance is built into the pipeline. And here is where the SQA has a special role, where they keep identifying what can be brought into the pipeline. They are not here to do mundane job which a machine can do. If there are rules which can be put into your static code rules or a dynamic static code analysis, or bring a security tool which is out there, either free or paid depending upon what the company can afford and so on, focus on that, bring into the pipeline. Don't focus on doing that manually. And that's the big role of an SQA, where they identify and put into the right pipeline, then ensure that that is quantitatively analyzed. So SQA has a different role today. I mean, you are not writing Excel sheets where you are deriving control charts and deriving PCBs. Yeah, I mean, people who are from quality, they know what I'm talking about. The process capability baseline. It's automatic. Process capability baseline can be made automatic. Your focus should be to do quantitative analysis of the build pipeline which is running. Then, of course, there are aspects related to, we can do all this technical stuff. But at the end of the day, the team culture is now, we have to build a strong value system where there is a good binding, good collaboration. The agile fundamentals should be brought in, and there is a constant learning and development that keeps going it. Yeah. So I will stop here. I will take a pause in the interest of time, and then have Jaga coming in and speaking about his experiences on Google. Yeah. Over to you, Jaga.
Oh, thank you, Anish. Yeah, I think I would touch a little bit more on the SQA, because I've been in this line for about I think 15, 16 years now, and it's been something that manual testing. We just click on the UI, and that's what testing is supposed to be, right? But over the years, what we have seen is testing has actually grown to the place wherein we try to figure out, like, we try to make decisions wherein how much can you minimize those manual testing is what is being smart. And that actually for me is what the next level of quality is going to be. So that's what I'm going to share with you. My experiences in this area. And what are the things we've done. So yeah, I think as Anish was talking about, we're talking about metrics, we're talking about data, right? So I wanted to give you a release pipeline, because sometimes when you try to visualize data. Sometimes you actually think about, oh, it's code metrics maybe, or review comments, or these are from the release pipeline, from the point at which a developer checks in the code and it actually ends up in production. So everything along the step is where you have data. You'll have data for, as I said, the person writing the code, the review comments which are coming on the code. Then when he submits it, when you have the test running it on that, how much time does test take to run on this code? Now, what kind of test that you have? Do you have smaller tests? Do you have medium tests? Do you have larger tests? Does it actually run as a part of a blocking, or do you have an offline tests which actually run, and how much time do they take? Once actually that's green, then what is the role of release management? Is that flow completely automated? If it is not, why it is not automated? Then as the things are pushed, like, it goes to the testing, it goes to testing is place where you can always have a team food or dog food where the developers themselves try it. Then you have a QA environment where the SQA specifically comes in. You actually test it with, and you can do an A/B testing. But overall, before it reaches, so you're looking at the point at which it starts to ends up in the binary. This is every day it happens, and whether you're launching a feature, whether you're not, this is a continuous cycle. So this is where I want to touch base that if you look at this flow, there are data everywhere. You can actually find out what a person is doing, which process, what is taking long time, and I can tell you that the process of optimizing this flow and getting quality signals out of this is a never-ending task. You can always find something new, something interesting, which will say, oh my God, this can actually replace something we already have existing. So that is how things become a little bit more interesting when you start looking at testing from the data point of view. It need not just be manual testing. We can move to the next slide. So next slide, please. Yes. So I think one of the examples that I would like to give here is where you can actually see that this is, I will give a disclaimer, this may not be applicable to all teams. This is specifically for teams which actually have really high traffic. And this was one of the cases wherein we used to have regressions. Regressions is basically when you put a new binary into prod, we would actually see either a CPU or a memory go up when you compare it with the previous bit. So we will always have a kind of a safety net wherein we do a comparison of a new release with an older one, either by kind of dividing up the traffic across two binaries, or have it structured in a way that, you have a set of users which are kind of differentiated, wherein that these set of saying that Europe gets up around this time, we've divided to two slots, two kind of buckets. And then what we do is when we actually release a new binary, we can actually do a comparison of A and B between these two binaries. So that process is well said, which actually helps us a lot in terms of avoiding our manual testing for us. So once we do that, we find a performance regression. So basically, when you know that as a performance problem, anytime you actually have a performance regression, what you generally do, you basically go back and you reach out to your load testing or performance testing team and say that, hey, can you find me where this bug is? Because there are so many changes which have gone into the binary in last, let's say, 1 week, that we have no idea what has caused this problem. So you need to have a load testing environment, but anybody who's actually worked in the load testing area will know that for a load testing or a performance testing to give you a stable results or a results which you can rely on, the amount of variance that you need is very, very low. That means it should be at the order of like 3% or 3%, and which is impossible. Like if you're, I think we'll have one of the presentators who's going to talk about maybe the service area or architecture. So in that, you'll always have that in your organization. You are taking care of specific service, but you will depend on other services to provide the backends, wherein you can talk to a specific service to get you the results for X, the other. So you will never be in a situation to actually have a hermetic environment where you can start all of these things up. So virtually impossible. But still, if you look at it, this is how it's going to come. You're going to have somebody that's higher up in the org who's going to say, I need a load testing environment, and you'll start going through it. It's a very, very painful process. But yeah, we did have this. Luckily, what happened is when we had failures in trying to do this, solve this problem, we actually started looking in a different direction. Like, what does data here tell us? Does data help us in any way? Can it actually optimize the process? A very kind of a place where we were never expecting, because we said, okay, when I look at this binary, the load testing team is not able to find this bug. So able to solve it, he's able to look at the profiles. So he gets the profiles and then he manually finds out what are the profiles which are changing. So you can imagine, and what we have found is these bugs were not something which and correlate. Oh, I think this could be because of this change which has gone last week. Oh, I'm seeing a profile which is actually going to this. Let's roll back this change. So it required that much of domain experience. So what we did was we said, okay, what are we trying to do? It's a very simple diffing problem. It's nothing too complex, nothing fancy. All you're trying to do is you're trying to get profiles from the new binary which is going in, and you're going to get a profile from the existing binary, which is basically, you can say that a control binary, which has everything work great. It's already in prod. And then when you do a diff between them to figure out where are the places where either my memory has increased or my CPU has increased, I would actually be able to find, as if anybody is looking into the profiles, you would actually see it goes down as a part of like, stack trace to the specific method. So it will give you chunk of specific functions where more memory. So you can always sort it out and figure out where most memory is allocated. And then give it to the developers, and where the developers can correlate this with what has changes happened so easily that we were able to bring down our 1 month blocking of this and as like top 5 and said, look into these change lists, and we were able to find. But as I said, Matthew, this was only applicable to places where there was really high traffic. We went to a different team, this won't work. So my suggestion would always be like, look at always like who's expert in the team, how are they able to try to solve the problem, and then see, can we do this? Because a lot of times as you go ahead, the solutions, the systems have become so complicated that I think it's going to be very difficult to find a solution manually, or trying to build a system which is like the existing solution. It's not going to work. So this is one of the things which I wanted to say, that and how we were able to find with respect to data. Now there are n number of things can be done. For example, at least metrics point of view, sometimes I've seen that people go crazy about metrics. You got to like, oh, let's do this, let's do this. My suggestion, we can move to the next slide, sorry. Yeah, no, previous one, sorry. This is the last one. Yeah, my suggestion would be to instrument your system automatically. That means to say, for you to get these metrics, do not have an extra step for anybody in the organization to do something extra. It should be implicit. Like if a person is writing the code, you should immediately get, like when a person is compiling, how much time the compilation took. When he's running the test, when they're running the test, how much time the test took. When they submit it, everything should be instrumented. Now, once things are instrumented, don't go crazy over all of the things. Try to figure out which is the long pole. You're always fighting the long pole. So get the long pole and try to optimize. And that's where you're going to be very critical in terms of what is the metric you want to do. Take a smaller step, iterate over it, improve it. It could be both the places. You will improve that either for productivity. And again, actually, I can tell you, the productivity also helps you to improve the quality. I've actually seen in the past, like if a developer is slowed down, if a developer is you should be as fast as possible. Once things are faster, invariably the quality will come. Then look into the system and try to figure out like, how can I catch? I was able to catch this problem later in the pipeline. What can be done to bring it now? And why should I get it? Because I want to get it early, because these are the maximum number of bugs which are there, and it's going to take time. So make those decisions in terms of what you want to get early in the life cycle based on this kind of analysis. Again, it's all background of data analysis. So the suggestion would always be like, the faster you get in terms of analysis, so I think ease of it, aggregating, please aggregate the data. Try to make sure like at least 20, 30 team member size, a binary size wherein we have. So that's going to give you a really amazing aggregation to understand like what's happening. The last, I think one of the very other things is, please do not think, always know that there's going to be one saying that, oh, as an organization, we want to get X metric and everybody should be within this range. Need not be, because based on the competence, based on the knowledge level of the team or the way the team works, the team try to get, because the more you start getting these data and analytics for all of them, it's going to become clear again. So try to select the ones which are required for your team. So that would be, for me, at least the basic simple ground rules that you can set for you to be able to understand how do you do the data analysis. Can we go to the last slide? Yes, these are some interesting use cases. The one I spoke about was the one which started. You've got to have integration testing, you've got to have maybe end-to-end testing, and then you talk about if at higher level you say load testing and performance testing, like stress testing would come in, all of those stuff come in, but that's like the bundle, functional and non-functional, and you break it down that way. But that project actually said you need to be doing these levels of testing, but you can try to solve the problem some other way, which is going to work really fine. So I think the other use cases which come in when you actually get the data with you is basically you can, for your tech stack, you can actually have a configuration which can automatically be created. You don't need to go and have a configuration done based on which are the servers you want to bring, what is the test you want to, you can always do that. I think the second one, we actually did this really well. It was very helpful for our developers in our organization is we were able to help them with the prediction. Like if a bug would come in, we would go back, and this was, as I said, don't go flashy about machine learning. Machine learning may not be everywhere. There are places. Machine learning is very useful when you actually have a lot of data and you have data which is correlated. So you have history of data. If you don't have it, don't try machine learning. In fact, sometimes just doing a normal rule-based system of if X, do Y, I think that's actually a better thing to do rather than doing machine learning. But this was the one where we were. So the concept is very simple. Like I know that in the past, somebody would have solved a bug like this, which is eventually, like many times it keeps repeating, the regression bugs come in. And based on how the text is written in terms of what the bug is, what we would try to do is we would try to go and search and figure out which are the bugs which are closer. Like we can always, I think apart from that, it can also find out which are the duplicate bugs. So a lot of smart decisions can be done, but this one was able to not just find an existing bug which was there, so the developers can see how it was solved in the past. It can also start predicting that based on the previous past experiences, you need to be looking into these flaky tests. Like you can actually predict which tests can actually become flaky based on the behavior changes that were happening. You can always do diffing. Diffing, I can tell you that, please look into diffing as one of the very potential ways of solving a lot of your testing issues. If you can actually have a system which is A and B, and you are able to get requests on both the sides, either by teeing up the traffic or having something similar the way you can simulate for them, my suggestion would be this will actually save you a lot of testing effort, plus you can build a lot of infrastructure on top of it to be able to do. So these are really interesting use cases that you can build, but everything is based on data. So that is how I think for me, when Anish is the data, I was able to correlate very easily saying that is how you can apply that onto testing and still get great results out of it. So that's my part of the presentation. Hopefully, let me know if you have any questions later.
Thank you, Jagga. Thank you for your points here. Thank you. Over to you, Prasanna.
Yeah, Anish. So we can, I think, skip this slide. Probably you already introduced me. Yes. Okay. So I'll thanks Anish, thanks Jagga, thanks for the folks who are here on a Saturday. I'll continue on the line what Anish and Jagga have been discussing. So a lot of my discussion is also oriented towards pipelines. But before that, let me set the dimension of complexity of typically what I do. If you see, this is a classical cloud computing diagram taken from Wikipedia. Right? With cloud computing, which is one core aspect of quality for Industry 4.0, there are too many pieces, what I call as an interdependent development system. It's no longer isolated development, that I have control over everything. In Oracle, when we are building cloud service, and that is even larger in Amazon and in Microsoft, or probably Google, is there are tens of thousands of developers working together to put a single humongous platform. So the AWS or Azure or say Oracle Cloud Infrastructure is a single large platform that thousands, tens of thousands of people are working and trying to put it together to work. So haven't we done this before? Yeah, I have done it before multiple times. Jaga has done it, Anish have done it. I come from a strong telecom background and also communication network background. We used to do it. We used to have large developers working together. We used to put large countrywide networks to work. But there, the difference was I had to roll out a network, say 3G network or something. I had 5 years time. I had protocols. I had guarding bodies with ETSI or ITUT to guard me. But in this cloud computing era, it's heavily interdependent and it's also become extremely rapid. And my journey on this has been in the kind of paradoxical, because Anish, can you go to the next slide, please? It's kind of paradoxical because we are trying to build a database cloud service. Of all the software components, in my opinion, database is probably the last remnant of a monolithic system. Every large database, or every database worth its salt today, is a monolithic system. Things which were developed in 1970s, which still run today, Oracles and DB2s, or which were developed recently, even maybe different kind of old DB or different kind of databases. Why they're monolithic? Fundamentally for two reasons. One reason is it's very hard to build it evolutionary. Okay, the data resides there, and if you fire a query, and the query should always return you a very, very accurate result. You cannot make it wrong. It's not, the database development has not been amenable to evolutionary development. It's been true. If we go to any of the large database conferences, we see that, oh, this has been a problem. How do we develop this evolutionary? It's not feasible. Okay, all of them work together. All of them are built together. Now, one end of the paradigm is still monolithic. Most of databases code, almost anywhere you go, even Spark and probably Hadoop is a bit better, but MongoDBs are also monolithic. Then cloud is extremely mobile. How do you manage them? This has been a challenge for us, particularly who was trying to put this to the cloud. Let me start about the one end of the paradigm, which is cloud. We have had two fundamental issues from day one. The first thing is scale. Okay. I don't mean horizontal scalability or vertical scalability software itself, but the scale of operations. Okay. We have software which runs at about 100 data centers in the world. Okay. Any delivery of a software has to scale to 100 data centers. Correct. And you get feedback from all those data centers. So a point what Jaga touched upon in the last part of the last slide. If you're running your software in 100 data centers and 10,000 users are using it, and your bugs get duplicated like anything. I've seen some cases where one bug is duplicated some 1,500 times in a single day. How do you cannot triage them. End of the day, it's one bug. If you try to triage them manually, where are the resources to do that? That is a scale. Fine, I fixed it. How do I deliver it across so many platforms? Say maybe it's a one bug, a severity one bug, or step two bug. How do I deliver it? It could be a 0-day vulnerability of security. How do we deliver it across? The pipeline is the core. So the scale has been first. The second one is the interdependence of software. Just coming from a strong database internal background, every architect or every technical leader, we used to be very proud. We know every piece of the software. Over the years, we have built that mastery. We have tried to understand every nitty-gritties and everything's predictable. But here, it's a beast. There are so many moving parts in the system, and then it's a hierarchy of software. Right? So we depend, say, on object stores. Object stores depend on computes. Maybe computes depend on networks. So it's hierarchy of software, and there are loops also. They interdepend on us. So there's no possible way for me to understand and appreciate all the implications. The parts are too many in the code. Okay. So this comes back to the point what Jaga mentioned initially. This service dependency makes the software, in my opinion, less determinable. You do not know how it is going to behave. It behaves one way today, it behaves a bit different tomorrow. And that is generally a very difficult thing for us coming from a very deterministic background. Okay. one of the manifestations you can normally see is the telecom network classically used to be very, very deterministic. Okay, you pick your phone call, you get a dial tone, you have essentially seized the 64 kbps channel. So no matter how many people are calling or speaking, your quality remains constant. But as we now see, maybe on a good day, your actual connection is good. On most of the days, it's flaky. It's because essentially the data communication network was self-resilient. And when you put anything on IP, it becomes self-resilient. So yes, it's resilient, but the determinism has gone down. Same behavior we're seeing with cloud. So the second part, even with all this lack of determinism, we have to keep the database stable. And the database code is old, is monolithic. There's no way we are going to rewrite it. That is impossible. And how do we deal with that? And finally, I primarily worked on database or product companies where we finish the product and deliver it. But now in a cloud service, we need to maintain it, handle it, then focus on operations, and attached with that, focus on security. Not only software security, operational security, and the certifications around it has been a challenge. So this has, in a way, building a cloud service for database has been paradoxical, and it's a good journey. So how did we handle it? So the first thing what we did was, it is impossible that we think every piece of software should have agility. Even 4 years before, Oracle used to release a database once in 3 years. We used to release software patches, yes, that's true, once in 3 years. Now we release once in a year, probably we'll go down to once in 6 months. 2 years before, we used to have Linux running at that same kind of cadence. So that was a reason to do it like that. It is not, we had to be very, very clear all the pieces work, and there are no regressions, or there's no break of backward compatibility. Maybe 1 million test cases normal, even in an open source project like Postgres, few 100,000 test cases run to ensure that your query processing is consistent. You make a change in the optimizer that it does not hurt running queries elsewhere. So this is the same rut you go through. So one part of the software has to be kept stable and grounded. The second part, that's another part which can continuously be evolved. So we segregated the whole thing into two. Then we start building resilience into the software. So it's a long journey. So because I'm the architect of autonomous database cloud services, started building autonomous entity into the system. What is autonomous? Resilience in terms of the first and foremost, in terms of we had 4 pieces. Self, you can do self-healing. If there is an issue, can you do self-healing? Can you switch over? It could be availability, reliability issues. Can we do self-configuration, where you can automatically tune the configurations, evolving configurations, and it could be also self-protection. Can we determine attacks? So this is 3 sets of things we are trying to build, and self-optimization. So try to build resilience in the software and also steadily layer the software so that you can prepare it for scale and delivery. So most of the software which we moving to this agility where operations related software, say it could be database administration related, or it could be installations, provisioning, those kind of things moved into faster cycles, moved into intelligent cycles, while the core of the RDBMS, the executor layers, the query processing layers remain constant. And the moment we have indeterminability, then we cannot guarantee the kind of quality what we could guarantee, say 4 years back, 5 years back on database software. So we have to deliver fast, which means we are taking bugs. That's a fact. Then the only way is to be agile in our response. How can we fix bugs when it hits us? So instead of assuming that we will not have bugs, we came to a state that we will have bugs. How do I reduce the impact of it? How do I turn it on? There are 3 things which we could do. First is, as I showed you, the complexity of the cloud is so big, right? So we need a very, very strong macro processes, because every piece I'm going to develop has a dependency on a different service, that has a dependency on another service. So it's a large, complex thing, and there are multiple teams working on it. So we have large macro processes, right? So our processes are dependent on cutting a series of Jira tickets. Then without Jira tickets, you don't move. You have specific release dates, you will not move with that. There are specific pipelines, they have to be clear, and then they have to be staged. So the whole thing is tied together. Then only we can ensure coordinated work. So in a way, these processes are remnant of it makes me my first CMM assessment was in 1998, CMM 4 assessment. When I attended, I was assessed. So then it is partly similar to that. You need coordinated processes because there's so many people running together, such a large group running together. We don't coordinate them. They're going to run into each other. That happens quite a while, and we have processes to do. The second critical part of the macro process is that you have to be able to roll back. You have to be able to upgrade. This is to be thought through. When we cut a Jira ticket for a change management, and I'm going to load this, then I always need to now mention that you have to. How will you roll back? Who will roll back? What is the procedure to roll back? Have you tested the rollback? Without that, we couldn't release the software because of it can break. There's always a possibility of break. Second one is I think a lot was discussed by Anish and Jaga. Very strong platforms for continuous delivery. Continuous integration has been a norm. Continuous delivery. For example, today by at least the database cloud service, if I have fixes, if I made a bug fix, I can roll it to 50 regions in under an hour with 3 stagings. It just goes to the CI pipeline, the pull request or the merge request goes through the CI pipeline, verifies that, then somebody merges it, and that goes to the set of pipeline, including security validations and including tests, and then goes to the staging area. There somebody clicks it and has a manual look at it, then approves the button, and then goes to one region which is staged, maybe in London, maybe in Hyderabad, maybe in Ashburn, staged, then again push a button, deploys across whole of the globe. This whole thing we can do in about an hour. That is the kind of delivery platforms that are required in this era. And then we are able to respond to it. How do we even determine that there is a problem? Right. That again is twofold. The first part is the complex. We have very complex and powerful monitoring systems. Most of these monitoring systems, we don't have a lot of intelligence in it. Unlike we still hope people we collect as much data as possible, put all of them together. Right. We collect the metrics, which are standard statistics. On top of it, we have logs which are attached with them and events which are attached with them. 3 signals. So juxtapose them and then let the experts or the operators have a look at it and flag the system. And that monitoring system eventually translates to a development system. So find you have a bug. It's happening on some cloud. How do you replicate the bug? How do you debug that on your localized system? So that has been another challenge where you can get a series of dumps and you can recreate your development environments to fix your bugs so the developer can play with it. They cannot enter into a production system. A cloud production system, especially a database cloud production system, which contains a lot of financial data, defense data, you're not allowed to enter there. Right? The operators only few people can enter there. Then how do you recreate the system so the bug can be fixed? That is monitoring and diagnostic systems. Not much about machine learning. Some part we have matching algorithms like to find duplicate defects, or like what Jaga told, it can point out which modules from a dump, we can point out which modules have bugs, we can do that. And further than that is to create the environment so that the developers can debug or the testers can recreate the test. And next slide. So the other thing is that because we are starting to operate these services, we are forced to bake in security into our development processes more and more and more. So security testing used to be an afterthought, but security testing now roughly, I believe, consumes 30 to 40% of our QA effort. So that is not only security in terms of pen tests and all those, also sometimes compliance tests where you have the SOX or SOX tests or stick tests, and those tests also are baked into this process. So you are keeping the compliance up, you're keeping the security up. And finally, which from a product organization, we had very little focus on operations. So now there's a lot of focus on operations. Operations is a first-class citizen. If it cannot be operated, the software cannot be delivered. So by operations, do you have enough statistics? Can it be rolled back like what I was discussing? That is an enhanced verification model. You just don't push a button and it's out in the market. Do you have staging areas? So multiple staging areas where we have almost a final model, and the operations team can manage it. If they can manage it, then only we can release the process. Summarize, Anish, next slide. If we summarize, then first and foremost is due to scale, there is lack of determinability, right? And that we respond by building agility in response and resilience. The second is we have to have better processes to manage this beast, and pipelines and intelligence monitoring. Second thing which we are very, very aware is if something cannot be agile, it has to be very, very stable. It has to be stable. There's no choice. Just because there's a fad, you cannot make it agile. That's a business case and also technology-driven decisions. That's a decision which many of the organizations have to make, which operate on mission-critical systems. This is what has been our experience in what I would term as a kind of paradox in this making the database software available on cloud. Thanks, Anish.
Thank you very much, Prasanna. Thank you. Over to you, Sojan.
Thank you, Anish. Thank you, Prasanna, Jaga. Yeah, we can skip the first slide, Anish. I wanted to take a bit more abstract approach to this presentation. When Anish, we spoke about this earlier, and I didn't know what quality 4.0 meant, and I'm not in the quality function, so I'm not familiar with the terms and technologies used in the quality. So I want to take something of what I'm familiar with and try to use an analogy to present my viewpoint to quality. Yeah. So I sail, and it's something. 2020 has been a disaster for me, but maybe this is giving me a chance to also talk a bit about sailing. So diving in, let's look at the picture in the northwest corner. This is a traditional sailboat. It's an ancient design, and this is how people used to sail hundreds of years back, and it was pretty common, constant for hundreds of years. You would have a hull in the shape as shown. You would have one or more sails, and you would happily cruise along at 4 to 5 knots of speed. 1 knot is around 1.8 kilometers per hour. But people used to travel the world with these kind of boats. And like I already said, this is constant. Things don't change for hundreds of years. And then, a little bit more recently, you started getting some more technology, and you had better construction material, and you have these boats like in the southwest corner. What I've shown here is a monohull cruiser, 30 to 40 to 50 feet. This is the kind of boat I have a license to sail. And again, this was pretty common or constant from point of view of technology for decades. Nothing much has changed. You have a similar shaped hull. You may have 1 or 2 hulls if it's a catamaran. You have 2 or 3 or 4 types of sails, and you would play around with it. And in sailing, something interesting is happens when you're going, let's say, at an angle towards the wind, or maybe even perpendicular to the wind. In theory, you can go faster than the wind, because as you go forward, you will feel more wind coming towards you, right? Which means you can take more power from that wind, and there's a positive feedback which happens. And in theory, you can go faster than the wind. Of course, this wasn't possible because of the drag of the water and other physics which prevent that feedback loop, positive feedback loop, from helping us. Windsurfers used to use it at a much smaller scale. But then suddenly technology changed, material sciences changed, simulation technologies changed, and suddenly well, it's not suddenly, it took a while, but in 2013, the AC-72 hydrofoiling catamaran design was introduced. AC stands for America's Cup. This is the sailing competition, and they publish standard designs. So all the boats have the same designs, and in this design, suddenly you have these big boats which are able to actually sail faster than the wind. And you do that by lifting the whole boat up out of water and reducing the contact area using hydrofoils. This was done before in power boats for a long time, but here we see it in a sailboat, just by the power of the wind, no electricity, no hydrocarbons. It's just by the power of the wind, converting that wind energy into forward power. So the top speed for this is 81 kilometers per hour, about 2.8 times the speed of the wind that is blowing. And then most recently you have the AC-75, which is a foiling monohull, which takes it even further. And literally this is more of a plane than a sailboat, right? You can see this picture. This is sponsored by Airbus, and this is able to go up to 50 knots, 92.6 kilometers per hour. Again, around 2.8, maybe up to 3 times to the speed of the wind that is blowing. These are massive boats, which the AC-72 is about 40 meters high, about 11 to 12 stories high. The AC-75 is a bit shorter, but they have wider sails. The reason why I want to bring this up is that it's not about industry 4.0, or it's not about quality 4.0. Any domain you get into, any area of technology we get into, there are similar changes happening, right? So it doesn't matter which industry you're in. There is this sudden use of increase in technology, increase in material sciences. Data, the amount of data you can generate and analyze and simulate is so much more than you can take things literally to the next level, as it has been done in sailing. Anish, can you switch to the next slide, please? Right. So here, what is that shift? On the left side you have the old, and the right side you have the new. And on the left side you have what we call incremental innovation, and this is very important. Of course, you put things together and build something new. For example, you have in the old days you had a mechanical calculator where you punch in some numbers and wind it up and it gives you an answer. I think it could add and multiply. And then there's the electric motor which was invented. So someone decided, okay, let me add these two together, and you get an electric calculator, which makes things fast, but there are limits to how fast you can go. On the right side, we make these big drastic jumps where there'll be some drastic and fundamental change in technology and ideas happen. And in the case of the calculator, the idea of Boolean mathematics and digital circuits come together to create the first electronic calculator, which is a huge jump from the mechanical calculator. And on the right, getting to the right side takes some creativity. Once you get on the right side, you jump back to the left side, and then based on that starting point, you add on top of it and do some more innovation. But there's a certain level to which you can go on the left side, and you have to go to the right side to make the next jump. And going to the right side is not about slight improvements. It's drastic and fundamental changes. It's about how close to the boundaries we can safely operate. Every piece of technology in one of those big sailboats has to operate at its optimum in order for them to lift the boat up and go at 80 kilometers per hour. If anything in between is not optimal, it's not going to work. How efficient can we be? How much of power can we get from the wind? How can we reduce the surface area of contact with water? We have to become more efficient, and optimizing each and every part of the system is crucial. And finally, increasing use of technology from other domains, sailing, new materials, new designs, new simulation techniques. All these things allow us to take this to the next level. Of course, we might say quality 4.0 and industry 4.0 now. It's a big thing, it's a new thing, but a year from now, it's just the old. It's the common thing. It's what everybody does, and then we'll be looking forward to what quality 5.0 is, or industry 5.0 is. Next slide, please, Anish. So my view is quality is engineering. I don't see quality as a separate discipline, even though there's this huge body around it and processes behind it. My view is it is a part of building stuff. And I see two aspects to quality. One is the ability to use the right technology. Data science, machine learning, AI is good. It's really powerful when used correctly, right? As Jagam already brought up earlier, you just can't apply it everywhere. Then there are modern programming languages which are evolving, which really improve quality in terms of memory safety, in terms of performance, and so on. My favorite modern new programming language is the Rust programming language, and I've written some articles on it which are available. It is not just Rust; there's a lot of other languages which are looking at improving memory safety and overall quality. Formal verification methods of software and systems. This is crucial when you're building big systems and you really can't understand the whole system, and you may need to have additional tools to verify the system you're building, and this becomes crucial when you want to do functional safety in the case of automotive, maybe also security when you're talking about bank level security systems where you need some formal verification of the system you're building. Is the code you're writing, it's not enough just to test and exercise all the parts. You also need to literally verify it mathematically that it is going to do the right thing. And the next one is system thinking, and I think this is very important. You need to understand the whole system, how it works as a whole. If you have a myopic view and try to optimize smaller bits of the system, what I've seen is sometimes we over-optimize some parts because we can, but this might compromise other parts of the system. So you have to look at the impact of an optimization on the entire system, and avoid getting into this over local optimization. And finally, it's a strong engineering foundation is absolutely crucial. Systems are getting complex. We need to push the boundaries to take things to the next level, right? You may have the best technology, or to take the example of the boat, you may have the latest and greatest AC-75 boat, but if you do not understand how to operate it, if you do not know how to keep the sails at the right angle to match the wind, it's just not going to work. So you have to understand technology and have a strong engineering foundation. And the next part of quality, I mean, that's the second aspect of quality. The first one was using the right technology. The second is equally important. So it's orthogonal and supporting each other. It's how you embed quality at every step. I like to use the term impedance matching because that's how I mentally understand it. And this is a term which is used in electrical engineering or communication or mechanical engineering, where how do you couple the right amount of energy between two elements of a system? If the impedances of the source and the sink are not matched, you're not going to get optimal coupling of energy, right? And I believe processes, the DevOps, agility, the agile processes, scaled agile, all these buzzwords, what they do is do an impedance match, right, between the different elements of your assembly line. And I think the exact technology use or exact process use is not so important. What is more important is it is matching across the organization. You cannot have one part of the organization doing one thing and then another part of the organization doing something completely different. And when these two meet and you have an impedance mismatch, and bad things happen. So I'd like to summarize the slide by saying no problem can be solved from the same level of consciousness that created it. I believe it is Einstein who said it, but I can't confirm because there are conflicting information about that, so I didn't right? Who said it? Let's say some famous person said this. The point is, we are building complex systems. If you want to ensure the right quality of these complex systems, if you want to test these complex systems, you do need to be at that same level of technology to infer information about it. So using what is apt is important. Don't just throw data science at everything. There is a lot of fundamental engineering concepts, also which are crucial. And about process, again, don't throw the latest and greatest process buzzword at your problem. Prasanna put it very well. There are certain parts of the system which cannot be agile. Don't attempt to make them agile. It applies to people as well and applies to systems as well. My last slide, Anish. Yeah. So I'm working in Harman in the connected car division, and connected car is also going through similar changes as I explained in the sailing analogy, right? So what is a car now? A car is an IoT device. A car is it's always connected. You have to worry about not only do you have to worry about the safety of the passenger, but now we're talking about cloud connectivity, transactions which are being made by the car on behalf of you. So there's a lot of security involvement in the vehicle. Then you have car sharing related use cases, charging use cases, and driving is just one of the aspects, one of the small aspects of the car. And what we're seeing is, the vehicle is now a source of data, a source of lots of data. The vehicle is also a sink for lots of data, and it's no longer a small embedded device which is just showing something up on screen and giving a navigation input to the driver and so on. It's much more complex. There's vast amounts of complexity in a vehicle, 3, 4, 5, 6 ECUs and the millions of lines of code, and it's not possible for one person to put everything in their head and understand the whole system. So using the techniques which Jagdish said, Prasanna said, right, having a strong pipeline, having a lot of automation where you can use it. You can't automate everything. Of course, we should attempt to automate as much as possible. You can't use machine learning on everything, but use it where applicable. And at the end of the day, it is good engineering practices which lead to good quality. That's my view. Thank you.
Sojan, thank you very much. Okay, so with this we have done with the presentation from all the panel members. So I will go to a few questions which we have prepared. I will just stop sharing with a moment. Okay, while we are having some open discussion, I will have also the attendees also share their questions also, and so that I can also take it up over the span of time. Okay, so I would say, I will put this question to all of our panel members. So how should, I would say the project management, quality, test, architect, developers see the role differently in the context of software 4.0 or quality 4.0, So I think all of us have shared our perspectives on this, and I think we know where we are coming from. But the fact is that there are frameworks which are there are methods, there are some things which are changing. How do you see we should see that differently, and how we should adapt ourselves, how we should reimagine ourselves from a profession standpoint? So anybody would like to pick up that?
Yeah, maybe I'll start. Anish is Prasanna here. So one thing what we've seen, especially I'll just cover all the roles. Managers, at least with the cloud transformation, what we have been seeing is this happened, Microsoft happened, Oracle, everywhere. We have smaller teams. There are essentially only two roles: a set of DevOps roles or QA DevOps roles, and there are managers. So those managers, because of all this pipeline and the way the agility is built in cloud-based software development, these managers are more outbound. Right? They write up the product. They can write up what could be classically termed as a product management kind of a role, that they can write up what is the software intended to do or a feature intended to do, and that is a continuous process. Especially if you want to release software every 2 weeks, they keep writing that. Maybe you have inner blogs and external blogs, evangelizing them. You have to put it to the dev community, monitor Stack Overflow, for example. There are questions. So that is the manager's role has become much more hands-on.
We're seeing a video lag. Maybe we can switch off our. I will also switch off my video.
Okay, I'll switch off the video. Yeah.
There's a lag in the video. Maybe I'm not sure whether it's only with me.
Okay. Anyways,
I'll stop the video.
Right. So yeah, that is, I think, hands-on managers and architects. I think both Sojan also touched upon. I also touched upon my session. Architects, at least for cloud, are wide-based architects. You need to know a lot of things and know something which is specific. Like previously, at least in my domain, when you do database, you need to know something very, very deeply. It is no longer that way. It is more wide-based. I think that is the second one. The third one for quality, I'll stop with that. The quality one is that if you have to do orchestrated software development and delivery, there are processes required. It's not that you cannot completely eliminate them. There are processes required to ensure this delivery happens smoothly, right? And also building up this cross development pipelines and what are those rules for them and what is the red light for releasing them. You have a CD 9.x vulnerability. Are you going to release software? You can't. So those kind of processes and broad gates essentially need to be driven down. So there is a re-identification of it. It's no longer metrics based. Metrics automatically picked by probably CD systems and they can be crunched by automated systems. This would be a change. Hands-on managers, wide-based architects, and macro processes being developed.
Thank you. Thank you, Prasanna, for sharing your perspective. Jaga or Sojan, you would like to say something on this?
I'll go Sojan here. I think
yes, Sojan.
The width of what Prasanna just said. So the lines between, let's say, a quality engineer and a development engineer is blurring, and I think that's really a good thing, right? So I just see themselves. I mean, I see myself as an engineer, and my responsibility is to build a solid product, right? And yes, there are some tools and processes which I have to keep in mind for building the quality product, and that's my impedance match problem I have to solve, and while I'm building systems with the right technology. So I think going forward, this separate quality organization, my view is good for, let's say, controlling the pipeline. But I think when you look at more towards the actual code that is being written, looking at the quality of those, that separation is no longer helping. I think that it should come together, working much closer together, and even be able to switch between the two. That's what I think is the way forward when it comes to at least the development team side of things.
Thank you, Sojan. Jaga, would you like to say something?
Yeah, I think overall, as I said, the system of a concept of somebody understanding things from black box testing. I feel those things are going to go away. I think you are a tester, whichever, but I think the understanding of how the system actually works, because as I said, nobody can actually validate it for 100% for sure. I think we had Prasanna who also was talking about, like, we'll always be ending up in a situation where we say, oh, there are going to be bugs in the system, right? But how do you catch them quickly? Which are the major ones that you want to catch? So sometimes you're going to be fighting that battle of finding critical issues. Small things can persist in the system and you want to roll it out. But I think this role about QA or the technical understanding of how the system works, again, the metrics comes into the picture, understanding what those metrics mean. All of that will actually play a big role in how we structure the quality as we go ahead. Because I think those roles by themselves are changing. it's going to be very close to how a SWE looks, but the passion towards how a system can break, or not just from the point like I do a few clicks on the UI and things are going to break the same, but overall because of this cloud system that we have, cloud computation, or how things are there, what is the one which needs priority? I think those things will become very, very important.
Thank you, Jaga, for bringing that point. I just want to add two points. Go ahead.
Sojan here. Yeah, just one point. So to give a good example from the automotive space, right? Let's say we are writing a passenger monitoring system, which is a driver monitoring system, looking at the driver, looking at whether the driver is concentrating or falling asleep. These days, this is done by using machine learning, neural net kind of systems, and it is really very hard to test such a system, right? Because it's using neural nets. Sometimes we don't even know why it is working the way it is working. There's a lot of theories behind it, yes, but how can you test the quality, right? So you have to rely on more statistical methods to really make sure that algorithm is working the way it is intended to. So that's again my viewpoint of you can't separate out testing from from the development in these kind of things. They have to be really closely tied together.
Okay. Thank you, Sojan, Jagga, and Prasanna for sharing your perspective. To summarize, I think all of us are bringing, the key point is that I think we need to be more hands-on. Yeah, I think Prasanna brought out that point. Go hands-on, and be more connected and ensure that we are on top of it whenever we are saying certain points. And Sojan brought out that, I mean, these are not two different things. Yeah, quality is not somebody separate department sitting and only doing some policing function. It's about that function sits, but there is a more accountability at all levels which is being driven, and we should use those frameworks and statistics or data to ensure that we make the right decision making based on that. Yeah. So Jag also brought out that certain aspects related to, I mean, there is only people doing black box, or certain roles are going to fade away. Yeah, and we need to reinvent ourselves depending upon how things are shaping up. Few words from my side as well, based on my experience. I also feel, I think, just in line with all of these thoughts, these tools or systems are to enable us, and every role has to reinvent this. For example, while we are preparing, we talked about today developer. I can't have only a developer who knows only that I will do only UI, yeah, only UI development. And there is a developer who will only do, say, middleware management or middleware development, or only a DB guy. Yeah, we may need specialists, but those may not be in large numbers. Yeah, so we need to have developers who can do full stack development. When you say full stack, it's no buzzword. It's like you can do end to end, right from your UI to your next level layer to the DB who knows all the expertise. You can quickly develop any of those aspects. Same way from a test perspective, I don't need only a person who do only manual testing, who sits, and we have a lot of teams doing only manual testing. So those differences are less, where manual testing is separate team, and an automation those days, I would say in large sense people are integrating. The tester means he or she should have good programming skills, who can develop good frameworks and ensure that whenever they're writing the test cases, they're also automating. That's one part of it. From a QA function, I say that we should, gone are those days where we say we take a big model like SIMMI, ASPICE. Still there are organizations who do that, but I would say the times are limited. They need to figure it out how we move forward in that in the right direction. So I mean, we should not get I would say tuned to one particular model. Like, see, a lot of marketing happens on some of these frameworks, whether it's agile. I don't want to pick on any one thing and create debate on that, but my point is, look into the organization's problem, organization's processes. Based on that, define the process. So QA is a right function who have a very in-depth knowledge about system, as like Sojan mentioned, have that system thinking, ensure that, look into the problem, cherry pick the right practices from the model and put into that. This is one of the unique skills which I would say, in my experience, a lot of other roles don't bring in directly into the table. So the project managers and the QA folks, I mean the process QA folks have the deep skills, I would say definitely we should capitalize on that rather than running for any very big models and say now let's do this holistically. If you see, I was doing a research about some of these top organizations, right? Either the Facebooks, the Google, or the Apple, or some of these organizations. Have you ever heard that they are adopted CMMI? Yeah. Have you heard that they have adopted some models like Agile Safe? In fact, they are doing it. If you see, they are doing it, but they are doing it based on the problems which is there in the organization. What is the problem they are trying to solve? Based on that, they are cherry picking this organization. I was reading to the Scrum latest release, which so I was listening to Sutherland and others. They were saying that from Apple also there are a lot of organizations. I mean, teams are using Scrum, but they use it, they adapt it to their context. So that is one other view which I have, and I wanted to say that. Other point is about more and more things. I think all of the speakers talked about continuous integration. I think that is the way forward. We must find ways out from a QA and a management standpoint that how we bring more and more things automated and still use data out of there to make better judgment and use the right tools from our kitty to use it intelligently. Yeah. Okay, so with this I go into my next question. So in your opinion, I think you have touched a little bit, but I would like to put this a very specific question on. So we have used machine learning or artificial intelligence. How do you think it can improve our software development? Yeah, I mean our software development at various parts. How we can use that, and do you have some views about it? When and how we can use this?
Okay, Sojan here. Maybe I can go first. I think we have to be careful because machine learning is basically statistics, right? It's all about statistics. So it's packaged nicely, but it is statistics at the end of the day, right? So I mean, if we don't understand the data which you're going to apply this to, it's not going to work. So we shouldn't come with an approach that this is going to somehow magically solve our problem. I think Jaga said it very well, right? If you don't have the historical data, this is not going to help you at all. So if you have the data, perhaps yes.
Super. Yep.
So one, hey, this Anish, Prasanna. So the one area which we are definitely seeing some traction for using machine learning and also not so much of AI, definitely machine learning is where we deal with operation ability, right? I mean, we are able to monitor. So we are able to monitor large amount of deployments where a lot of traffic is going on, a lot of operations are happening, and that essentially removes the first barrier where we have enough data, right? And it also removes second barrier. Generally, the norm is that's a good percentile which we can bucket as normal. So the abnormalities stick out more easily, correct? And typical like what they find with credit card frauds or something, where a large portion, you have large amount of data, and a large portion of the data can be classified as normal easily. So that we are able to see, and so operations is something that we are able to use. That improves the builds on the point what I made, that the determinability of the software being poor, finding problems sooner helps. So that is one area where it will continue to grow. That's something which we should be able to use, I believe, in deployments. And cloud being the norm of development, so most of the products moving from product development, product delivery to a subscription-based model or hosted delivery models, this would help.
Sure. Got it. Okay, Jaga, would you like to make any words? I think you already covered it in some sense, right? You used it intelligently. Yeah, I mean, that's what you also talked about in your talk as well.
Yeah, exactly. The thing is, and basically he was managing a machine learning team, and I went to him and I was like, I want to do a project which is machine learning which can do testing on its own. I kind of pitched in some weird ideas on this. So he made me sit down and he said, see, you can't apply it all the places. Then he gave me this idea about the bug and predicting the way to fix. He said, now this is definitive. So thinking we can apply, but I don't think it's possible. Like when we launch as a part of the process, when we launch a new binary, we get integration test coverage, we get the bugs open. So if you look at it at some point of time, if you are able to correlate, like once everything is done, and then of course, but that amount to this particular feature, if all of those things fall perfectly fine, and then with that correlation, and you have enough data, maybe you can predict at the time of launch saying that this feature which is rolling out might be buggy, but until that mapping happens or until that accuracy of those things actually happen, it is human. We should be able to make a decision. When the data becomes big, we can actually have it to it, but right as a very use it as, I think tests were another example where I could easily use it. The number of tests automation which are running done in those areas because just the data exists, a lot of data exists there.
So, Anish, I'll add a caution right on the same lines for both Sojan and Jagdish. Right, this is something which we faced. We used to have some learning algorithms which used to monitor a bunch of logs and then cut Jira tickets or raise bugs automatically. Okay. The way it is, if I cut the 712 ticket, it will directly send the PagerDuty or Slack the corresponding, and it will also find who's on call that day and Slack it. We had in certain cases we have huge amount of false positives, and that you get paged, and then that guy is scrambling to fix the bug and find it's a false positive. Then eventually your trust on the system goes. I mean, they are not going to the classical wolf story, right? You are not. Then the operator stop responding to this. So unless we had to build blackouts so that in those cases it will not happen, so that it doesn't proliferate. It will be pretty careful. But once it's stabilized, a lot of dryness there, then we can go full automatic. But even then, I think it should be careful. They be paid dearly, I think.
Correct. Yeah, that's a good point. So I'd like to bring a more embedded system perspective, right? In my view, there are two types of errors that can happen in the system. One kind of error is what you can try to test the system, give it bad inputs, give it the right inputs, or give it boundary inputs, and if it's not coded well, it's going to fail. These kind of, let's say, failures are quote unquote easy to reproduce. I want to say that easy because you can do it by trying to exercise those bad code parts. But especially in systems programming, there are a different type of errors which are very non-deterministic, right? So when you're programming in C or C++, you have, for example, the use after free errors, right? Or memory corruptions or data races, which are incredibly non-deterministic. It happened once in this way, and next time it happens 2 months later in a completely different way. And no matter how much data you collect, that you cannot do any sort of correlation in these kind of problems. And I think from a system software point of view, lower level software point of view, where the languages are much closer to the hardware, it's not really feasible to use machine learning, right? You really need improved development tools to avoid introducing this problem in the first place. So here I would like to pitch again for my favorite language, system programming language, which is Rust, which is trying to solve this problem in a very elegant way. You really can write safe, memory safe software without data races, which I think 2019 there were, I think, quite a few of the security vulnerabilities reported in the CVE was due to such issues, right? Most of the security problems are because of these kind of data races or use after free problems. and you have to cut this, very early on in the development process. We can't solve it later.
Correct. So next we should have a session from you, Sojan, on Rust programming. Yeah, we can solve the world's problem of memory related problems, race conditions, and so on. Yeah, that would be interesting. Super. So thank you, Sojan. Thank you, Prasanna and Jagga. So I would have the audience having questions. I would give time for that. I already see some questions. I see Suresh having a question. We have seen the fitness functions as are part of design. Yes, is the quality 4.0 are also getting included as part of product characteristics or quality requirements in the recent? Okay, it got cut after recent. So let me see if I can have him unmute, and yeah, if I can hear out from him directly. So Suresh, I will just unmute if you want to speak out and put your question. Let me just. Suresh, can you speak? Are you able to speak? Can
Hello.
you check? Hey,
hello. Yeah,
yes.
Thank you. Thanks, Anish. So, yeah, I think more or less same. So, we have seen that fitness for functions are included in the design, say the performance aspects or the reliability aspects. Such a way, like the reason how the quality 4.0 anything part of your product characteristics, or how it has been taken.
Okay. Sure. Maybe I will start, and maybe others can take that question in their own perspective. So if you see from a quality 4.0 perspective, at the end of the day, quality 4.0 is using the right in the context of right technologies, basically big data or cloud or IoT, to ensure that the use case scenario for a particular product or a particular scenario which we are developing, that has to be catered to. So keeping that in mind, I would give my favorite example of our telematics unit, right, where you have the ECUs or TCUs getting connected to the edge and getting the whole thing connect. I mean, the whatever analysis that comes back about either driver behavior analysis or whatever analysis that comes out, that goes back to either the various service providers or whatever people who have taken for that service. So the point here is that quality 4.0 are those ingredients, those are taken as part of that automatically become part of those fitness function or quality characteristics. So those performance or reliability or any of those parameters are part of those quality characteristics that has to be taken care as part of the development. So that's how I would see that getting implemented. Okay, but I will have others also chime in if they have any other views.
Nothing to add from me, Anish.
Okay, sure. So
Thanks,
I hope it covered that. Anybody else have any other question, thoughts? Can you please put across?
Anish, there is one more question, I think.
Yeah, let me just pick that up. I have. Yep. Quality 4.0 is for all industries, not limited to IT. Can the panelists draw 4 or 5 bullet points of what quality 4.0? I guess quality 4.0 should be derived from industry 4.0. Okay, I mean there are 3 questions, I believe, right? So Lakshmanan has this question. Quality 4.0 is for all industries, true, not limited to IT. Yes, that's correct, Lakshmanan. I mean, if I can take that and others can chime in, that's for all industries. In fact, this quality 4.0 is derived from industry 4.0. It's a part of that, right? I mean, I don't think quality 4.0 is something which exists in independent. It's part of industry 4.0 on everything, and primarily this is coming from the manufacturing and all those related, how we can have smart manufacturing, additive manufacturing, and 3D printing. There are so many different industries which is getting affected, or I would say motivated with this change which is there in the technology. This particular panel discussion we are very specifically focused on because the panelists are coming from a similar experience on either cloud, big data, or AI, IoT, and related aspects. So we are very specifically focused on software specific, quality, software quality 4.0. But I hope, along with ASQ, we can have more organized event where we can also focus on some of the other industries like manufacturing or some of the other areas as well. So I would say our focus has been on these areas. That's the reason we have a little bit zoomed into the software quality side of things, or software side of various aspects related to all of these areas. Yeah. Lakshman, if you want, anybody else would like to add anything, if on whatever if I missed out anything. Okay, I will also have. I am not sure whether Lakshman want to add anything from his perspective. I will unmute you, Lakshmanan, if you wanted to add anything from your side as well. You're unmuted. You can talk if you have any other points. Yeah.
Good morning, everybody. Thank you for this nice session. Industry 4.0 by itself has few characteristics or few elements to it. So I would like to hear from the panelists in a very specific way. It should be very specific. That what exactly quality 4.0, which when derived from the elements of industry 4.0. Maybe I would like to, because I'm when I attended the session, we do hear about so many things which are in fact happening even outside this industry 4.0 or quality 4.0, because they are happening even outside this umbrella. So what I would like to hear is very specifically what quality 4.0 when derived out of industry 4.0 means. It shall not be generic, my humble request.
Yeah. So Lakshman, yeah, I will maybe take up that. See, it's I would say some of these things are evolving. Yeah, I think I was having a discussion with Anandya also. These areas are not something which is written on the wall, and this is the kind of, there is no body which is right now saying that this is what is quality 4.0, this is derived from industry 4.0. But we are seeing a broad pattern in which organizations are working. If you see the experiences from which our folks are coming in, whether either Google or Samsung Harman or from Oracle, all of these experiences are talking about large system getting developed either in the context of a connected car or in the context of Oracle, where we are developing DB or a large infrastructure related to that, or Google as a whole. I mean, the experiences where Jaga comes from is about developing Google Product Suite and G Suite. So in that context, basically, how we can apply some of these quality parameters. So if you see, we talked about pipeline, the continuous integration pipeline, how we can have all of these quality built into that pipeline. Now, when we say quality built into the pipeline, what do you mean by quality built into the pipeline? It means that how are you designing your continuous integration pipeline? First of all, you need to see your architecture in view and ensure that all of those aspects, which is from the product fitness function, what are those parameters? For example, if you have a reliability, somebody talked, I think Sojan talked about memory related problems which may come in, or all of these things. How are we bringing in the right tools into the continuous integration pipeline so that we can get alerts on time? Can we bring in, somebody talked about security, can we bake in security into our pipeline so that we can get right alerts? Now, I would say 5 years back or 10 or 15 years back, this would have been very difficult for us, because you would have to have a separate team doing a security analysis and so on. But today, at a click of a button, you get all of these things. I would say, while we all want to give a very, very pointed answer that this is what is quality 4.0 and this is a mantra, but personally speaking, I don't have one dotted answer that this is what the list of all practices which will take us there, because a lot of things are about the way we collaborate, the way we come as a whole holistic unit. But I think the coming months or days, we will have something on this fashion where we are going to collaborate and come out with some of these things. Yeah. So anybody else would like to add, maybe any other?
Yeah, I think I can add a little bit to this, because Google as a whole also is a set of teams or basically products wherein they're vastly different. Some of them are software, a lot of them are hardware, and right, where we can get these metrics. We can actually, as we spoke about, the release pipeline or the pipeline that you spoke about is constant. But how each team implements it, or what's like a software point of view, you can always say that we can always do something has to release on iOS, cannot do it that fast. But it doesn't stop us from saying that what are these practices, and the software. Let's say I just give one of the binaries that we were working in. The release of that was, I think earlier it was once every 3 weeks. I think we took it as a project to say that how we can change it. We got it to 2 weeks, then we got it to 1 week. Now it's every 3 days. So now that binary which we got it at a front-end server was like a month. We then pulled it back. That resulted not just because of there were these practices that were built. We actually had to go back and re-architect the system, because we said, okay, the way the system is written, it cannot be. So I think there was a lot of effort in terms of the testability aspect of the system that was built in. Then we looked into like, as I spoke about A/B testing, it said this is not possible. Oh, now we have to do this. What will happen? We do. Oh, the dog fooding concept of that was not possible. If that has to be done, what do we need to build in? So the best thing about this is you may not find a solution which will exactly cater to your requirement, right? But I think you have enough practices out there for you to be able to pick and say, how does this apply to my industry? And if I put it on my industry and my hardware or anything like, how does this work? And that will help you to pull things back. So I think in fact, I would actually say that if you're not in IT, if you're not in IT, you're actually lucky, because there are a lot of innovation that still needs to be done, and you will be a part of it to pull it back. But that's how it happens. We started started optimizing it. You have a reference point, use that reference point to bring it back and make it as far as the reliable release pipeline. And I can tell you, 2-3 years down the line, we will be talking the same state for all the other industries too.
Anish, I would like to jump in with 2 thoughts here as well.
Sure.
So I would say, look at from the perspective that there will be, I would say, 3 kind of folks which will be there. One would be the kind of folks which will be known as developers, the kind of people who are talking here today. And they would be talking about how quality gets integrated here in their processes. And very aptly said by Anish that it's evolving. It's still fuzzy. There is a lot of things getting involved. Things are growing. So everybody is learning today. Okay. So there will be one set of folks who will be pure tech, who will be looking at developing this and maturing this particular technology. The second set of folks would be the folks which would be collaborating with would be the tech folks and the end user folks, and this is where the collaboration will come into play. Say, for example, a lot of examples been talked about automotive industry, and that's something that Anish and Sojan both touched upon. I would say then it's a mere collaboration of hard product and software talking to each other. That's another set of integration that is happening, and there will be those set of people who will be looking at, okay, I'm developing a software specifically how a particular product will function. It's a hard product, and that's one. There will be another set of. That's where I would say the collaboration. Collaboration would be there in all places, and then other would be pure end user perspective, wherein there will be multiple. I would say as things evolve, there would be people like us. I would say like me, who are not a techie here. I'm a non-techie completely, but would be able to use software to my own benefit. Okay, if you step back, I would say 5-6 years back, and all those things, or I would say a decade back, the smartphone wasn't there. Now the smartphone everybody is using today. Even a rickshawala is using it today, and he's also using it to the benefit that can I get more business out of it. So he's also looking at using the technology. So that's the end user, and that end user will also have an opportunity that there would be technology on AI or any other thing with which he or she would be able to use for his own, whether it is business or whatever. It will evolve. All the various platforms, social platforms will evolve. So those will be the 3 set of folks as I see it, and of course there would be separate conversation around each of them, and it will keep on evolving. And that's what I think we would be looking at when we cannot pinpoint that we have found a solution to Quality 4.0. ASQ started the discussion of Quality 4.0 3 years back. Last year not last year, I would say this year we launched the Quality 4.0 study which has been done with Boston Consulting Group and ASQ put together along with German Association. You know, Industry 4.0 started from Germany itself. That's the first thing, you know, and there's a lot of collaboration that is happening. And I would say that we still don't have entire answer, but as I said right in the beginning is that we'll keep on evolving. This is just the start. We have the tech folks talking about what they're doing, how they're looking at quality, how they're integrating in their development process, something like that. And I think it's a learning here, and we would all continue to learn, continue to evolve, and we'll keep on adding more that, okay, I think this has also worked, that has also worked. And tomorrow probably we'll have a body of knowledge purely for the software folks, wherein we look guys, if you want to be a real tech master in quality 4.0 from the software development perspective, this is the skill sets you need to have. Maybe you know, certain set of tool. Today we have Python, we have R. Tomorrow we'll have XYZ and others, which would be maybe a certain set of aspect of the tool, or the entire tool would be required in part of the learning itself. The other set of folks would be the end user folks, where we would say, look, in order to be more relevant, these are the set of 10 skill set or 20 skill sets, and each of these skill sets would always, as underlining, I think Prasanna, Jaga had mentioned about that, it's all about statistics, right? There is a lot of statistics that's going on, and then it will be, and those statistics will also get evolved, and it will become much more easier for us to handle. Only thing is that how we are looking at the number, how we are interpreting the number would be the entire difference. That's my 2 pence thoughts. Anish, I thought I'll share here.
Thank you, Andrea. Thank you for pitching in and sharing the point. I think we are almost on time, and I have one last question from Surya, which I will take it up and then we will summarize. In your opinion, how quality 4.0 can be derived, adopted, and implemented in R&D phase or activity? I hope I had that answer for that, yeah, in a very, very seamless way. I think Anandya already said that. So I think we all shared something. I'm very sure we have got some tips out of it. And while there is no one way we can say that this is the way we can go, but we can take tips from some of those, something which I shared about, you know, some of how we can take it from and put it into the, you know, continuous integration if you're following, how we can take it there. Jaga talked about how we can take the test practices, how we can, you know, monitor it in a seamless way using data and metrics and so on. Prasanna talked about how we can scale and how we can build that resilience in the system using the right methods. And Sojan talked about how we can have two aspects, using the technology and using the process, how to bake that technology into the process. I would say we kind of brought in, and that's the kind of a summary I would like to say, you know, with which we can use it. And there is no one-stop practices which can be. We have our own experiences which we shared, and some of these things can be applicable to you, maybe not applicable to you as well. But I'm very sure you have to contextualize any organization which we are in. We have to contextualize, for example, same machine learning algorithm you will be using for some other purpose. Maybe somebody else is using for some other purpose. Yeah, but you have to adopt it, use it rightly, and not for the heck of it. Otherwise, it will be counterproductive. I think with those words, I would like to summarize. May I request all of you to, you know, all the panelists to switch on their videos for a moment, and you too. And I would just want to thank all of you for your contributions and coming forward. I know all of us have a day job and taking time off you or from your busy schedule. Thank you, Anandya, for giving this platform and you know, and help us be coming together and, you know, share this. Thank you to Sojan. Sojan, thank you very much. Jaga, I know it's late in California, USA, so thank you from joining so late and staying till the end. Yeah, thank you. And special thanks also to Prasanna for jumping in. I know you have been doing late night releases, mornings we had to meet. Thank you very much for all of you to putting all of these things together. My appreciations, and thank you again.
Thank you. Thank you.
Thank you.
Thank you, Jaga. Thank you, Prasanna. Thank you, Sojan. Pleasure having you. Thank you.
Thank you.
Bye. Thank you.
Thank you.
Bye.
Stay safe. Yeah.
Bye. Bye.
Thank you. Bye-bye.
1 second. I want to stop. Have you stopped the recording?